dear students. Today we shall be discussing food packaging. Before discussing various types of food packaging materials in detail, let us first know something about packaging of food. Food packaging is a part of packaging technology that enables food to stay healthy and nutritious over a period of time. The functions of food packaging are to protect the food from external damage and contamination, to contain the product during transport, and provide information about the package contents to consumers. The important characteristics to determine the most appropriate packaging system for a food include the nature of the product, whether fresh, dried, frozen or processed, its physical form and mechanical properties such as size, weight, material consistency, fluid powder and composition such as pH, fat content. Now coming to benefits and value of food packaging. The benefits or the basic functions of packaging are: first, to contain the product in its physical form and nature; second, to prevent mechanical damage due to the hazards of distribution; third, to prevent or inhibit chemical changes, biochemical changes and microbiological spoilage; fourth, to provide information about legal requirements and product ingredients; fifth, to provide convenience to the pack handlers and users throughout the packaging chain; sixth, to market the food material through use of different shapes, size, color, etc. seventh, to communicate about the brand by the use of typography, symbols, illustrations. Now coming to the packaging systems. Packaging systems can be categorized into three main groups: primary packaging, secondary packaging, distribution or tertiary packaging. Firstly, starting with primary packaging. The first level package that directly contacts the product is referred to as the primary package. The main function is to contain and preserve the product. Examples include a beverage can, a paper envelope for a tea bag. The second is the secondary packaging. The secondary package contains two or more primary packages and protects the primary packages from damage during shipment and storage. Examples include shrink wrap that bundles two or more contents together to enhance ease of handling. Last one is the tertiary package or distribution package. The tertiary package is the shipping container which typically contains a number of secondary packages. Its main function is to protect the product during distribution and to provide for efficient handling. Now starting with materials for food packaging. First in the category are the plastics. Plastics are a group of polymers that can be formed into a wide variety of shapes using controlled heat and pressure. Now coming to the types of plastics. There are various types of plastics. Each plastic has its own unique properties based on its chemical composition, starting with polyethylene or PE. Polyethylene is usually the most economical choice of consumers. It is of two types: high density polyethylene and low density polyethylene. Low density polyethylene is softer and more flexible and has lower tensile strength than high density polyethylene. Common applications for low density polyethylene include stretch wraps, shrink wraps and many types of bags and pouches like LDPE. HDPE has good oil and grease resistance. It has better barrier properties than low density polyethylene. The improved stiffness of high density polyethylene makes it more suitable for rigid or semi-rigid packaging applications such as bottles, tubs and trays. Now coming to polypropylene or PP. Barrier properties of polypropylene are similar to those of high density polyethylene. It is a good water vapor barrier but a poor gas barrier. Polypropylene is suitable for use with products that require moderately high temperatures such as hot filling. One of the main uses of polypropylene in food packaging is in closure caps. Now the third one, polystyrene or PS. Polystyrene is a linear addition polymer of styrene resulting in a benzene ring attached to every other carbon in the main polymer chain. It is brittle, clear and has high surface gloss. The use of polystyrene in food packaging is only aesthetic, as polystyrene has poor water vapor and gas barrier properties. Typical applications include produce and meat trays, lids for drink cups, and inexpensive party glasses. Now the fourth one, polyester or PET. Polyethylene terephthalate, or commonly known as PET, is commonly produced by the reaction of ethylene glycol and terephthalic acid. PET is stable over a wide range of temperatures. The properties of PET are attractive as a food packaging material. It has very high mechanical strength, good chemical resistance, lightweight, excellent clarity, and reasonably high barrier properties. Now coming to polyvinyl chloride or PVC. Polyvinyl chloride is produced from vinyl chloride monomers. PVC has high toughness and strength, good dimensional stability and clarity, excellent oil barrier properties, and good heat sealability. Now coming to polyvinylidene chloride or PVDC. Polyvinylidene chloride is also a very heat sensitive material. PVDC can be modified with various co-monomers, typically in amounts between 6% and 28%. Properties of PVDC depend on the type as well as the amount of the co-monomer. The most noticeable benefit of this plastic is its excellent barrier properties against water vapor, odors, flavors, and gases. Now the polyamides, PA or nylon. It is formed by the condensation polymerization of a diamine and a dibasic acid by polymerization of certain amino acids. Polyamides in general provide excellent optical clarity, oil, and chemical resistance, and mechanical strength over a wide range of temperatures. The use of polyamides is often found in the form of film for high temperature sterilization or hot filling applications. Polyamides also act as flavor and gas barriers but have poor water vapor barrier properties. Now the polycarbonates or PC. Polycarbonates is made from carbonic acid and bisphenol A. The material is a very tough and rigid plastic with excellent clarity. However, it has a relatively high permeability to both water vapor and gases. Thus, it must be coated if good barrier properties are required. Its main packaging uses are large refillable water bottles and refillable milk jugs. Now coming to the processing of plastics. Processing of plastics involves extrusion, thermoforming, and molding. Starting with extrusion. In the extruder, thermoplastics are mixed and softened, which enables shaping into some desired form when they reach an optimum temperature and pressure. After extrusion occurs thermoforming. In thermoforming, a plastic sheet heated to its optimum temperature near its melting temperature is placed over a mold and pressure is applied to stretch it into a designed shape. Lastly, molding of plastics into final shape takes place. Molding means to form an object out of a malleable material. It is usually of two types, injection molding and blow molding. In an injection molding operation, the molten plastic is injected into a mold with the desired shape and cooled and ejected from the mold. It is widely used for making threaded closures of caps, tubs, and jars. Whereas blow molding is a process where a parison is surrounded by a mold with the desired shape and air is blown into the parison to force it to expand against the wall of the mold. The mold is then opened and the solidified product is ejected. Now coming to papers and paper-based materials. More than 95% of paper is made from wood. Making pulp is the initial stage in making paper or paper boards, and the quality of the paper is closely related to the quality of the pulp. Pulping can be done using mechanical, chemical, or a combination process. Mechanical pulping produces papers that are characterized by relatively high bulk and low strength as well as relatively low cost. Chemical pulping produces stronger and higher quality paper and is also more expensive. Now coming to types of paper and their applications. Different varieties of papers are used in packaging applications. The major types of papers used for food packaging are kraft paper, bleached paper, greaseproof and glassine, waxed paper and vegetable parchments. Starting with craft paper. Craft paper is made using the chemical pulping process and is usually produced from softwood. Unbleached craft is the strongest and the most economical type of paper. Now second, bleached paper. Bleached paper is produced using bleached pulps that are relatively white, bright and soft. Its whiteness enhances print quality and aesthetic appeal. It is generally weaker than unbleached paper. The type of paper is used uncoated for fancy bags, envelopes and labels. Now third, greaseproof and glassine. Greaseproof is a dense, opaque, non-porous paper made from highly refined bleached craft pulp. The prolonged heating during processing results in short fibers. It does not have complete oil barrier but is still fairly resistant to oil. These papers are often used for packaging butter and other fatty foods. Now the fourth one, waxed paper. Waxed paper is produced by adding paraffin wax to one or both sides of the paper during drying. The major types are dry waxed, wet waxed and wax laminated. Dry waxed paper is produced using a heated roller to allow the wax to soak into the paper. Wet waxed paper is produced when the wax is cooled quickly after it is applied so that the wax remains on the surface of the paper. Wax laminated paper is bonded with a continuous film of wax which acts as an adhesive so that it can provide both moisture barrier and a heat sealable layer. Now the fifth one, vegetable parchment. Vegetable parchment is odorless, tasteless, resists boiling temperature and has a fiber-free surface. Labels and inserts on products with high oil or grease content are frequently made from parchments. Now coming to paperboards and their applications. Paperboards for food packaging generally includes whiteboard, liner board, food board, carton board, chipboard and corrugated boards. Starting with whiteboards. Whiteboard is made with a bleached pulp liner on one or both sides to improve appearance and printability, and the remaining part is filled with low-grade mechanical pulp. It is used for ice cream, chocolate and frozen food cartons. Now the second one, liner board. Liner board is usually made from softwood, craft paper and is used for the solid surfaces of corrugated board. Now the third one, food board. Food board is used to produce cartons that are suitable for direct food contact. Food board can be used for all types of foods, particularly frozen and baked foods. Now the fourth one, carton board or box boards. Carton board is used to make folding cartons and other types of boxes. To improve its appearance, it may be clay coated on one or both sides. Now the fifth one, chipboards. Chipboard is the lowest quality and lowest cost paperboard made from 100% recycled fiber and is not used in direct contact with foods. Outer cartons for tea and breakfast cereals are some examples. Now the corrugated boards. Corrugated board has an outer and inner lining of craft paper with a central corrugating fluted material. They are commonly used in shipping containers. Now coming to metals. For food packaging, three types of metal are commonly used: steel, aluminum and tin. Steel and aluminum are commonly used in production of food cans and are the primary materials for metal packaging. Food cans are most often made of steel and beverage cans are usually produced from aluminum. Also tin plate, a composite of tin and steel made by electrolytic coating of bare steel with a thin layer of tin is used. Now coming to types of cans. There are two basic styles of cans, 3-piece can and 2-piece can. As the name indicates, a 3-piece can is made from 3 pieces, a body blank and 2 ends. And a 2-piece can is made from 2 pieces, 1 body and 1 end. Now coming to metal foil and containers. Aluminum foil is the most commonly produced metal foil. It is manufactured by passing aluminum sheet between a series of rollers under pressure. Foil is widely used for wraps and trays for ready-to-eat meals. Aluminum foil has excellent barrier properties against gases and water vapor. Thus, it is also used as the barrier material in laminated films for packages, such as those in retort pouches. Now coming to coatings used in metal cans. One of the major problems associated with metal packaging is corrosion. Therefore, inside of a can is normally coated to prevent interaction between the can and its contents. Coatings used in cans need to provide an inert barrier. The coating must adhere well to the metal and be non-toxic. The commonly used coating materials for food packaging include the following: epoxy phenolic compounds, vinyl compounds, phenolic lacquers, polybutadiene lacquers, acrylic lacquers, and epoxyamine lacquers. Starting with epoxy phenolic compounds. They are used for all types of steels and cans. They are resistant to acids and have good heat resistance and flexibility. They are especially suitable for acidic products. Examples include beer, soft drinks, meat, fish, fruits and vegetables. Now the second one, vinyl compounds. They have a good adhesion and flexibility and are resistant to acid and alkaline products. However, they are not suitable for high temperature processes such as retorting of food. Now the third one, phenolic lacquers. They are resistant to acid and sulfide compounds. They are used for acid fruits, fish, meats, soups and vegetables. Now the fourth, polybutadiene lacquers. They have a good adhesion, chemical resistance and high heat resistance. They are used for beer and soft drinks, soups and vegetables. Now the fifth one, acrylic lacquers. They are expensive coating materials. They take heat processing well and provide an excellent white coat. They are used both internally and externally for fruit and vegetables. Now the sixth one, epoxyamine lacquers. Epoxyamine have excellent adhesion, heat and abrasion resistance and flexibility and no off flavor. They are used for beer and soft drinks, dairy products and fish. Now lastly we shall come to glass. Glass is defined as an amorphous inorganic product of fusion that has been cooled to a rigid condition without crystallizing. For food packaging, bottles or jars are the types of glass packaging most often used, bottles being the primary use. Now coming to the forming of glass. Glass is made primarily of silica derived from sand or sandstone. The glass making process begins with weighing and mixing of the raw materials and introduction of the raw material to the glass melting surface, which is maintained at approximately 1500 degrees Celsius. In the melting furnace, the solid materials are converted to liquid, homogenized, refined and getting out the bubbles. It's all about this topic. Hope you have it well. Thank you.